Hello, I'm Emmanuel Lajeunesse, and this is my NXT submission for 2018. If I go here, you can see that I have the simple pinball game moving back and forth. I got the flippers that move the pinball around. It's bouncing between lines and also between the hole. If it dies, then it just kind of resets, and then you can press the space bar to just spawn it there. And that's the simple gist of it. It's got a scene changer from scene to scene. It's got a simple emitter just for nice effects and some text to show what's going on. And that's the simple showcase of it. If I look in the code here, we have the math classes that have all been written. I've got the matrices, the vertices, quaternions, transform class, which just kind of takes care, of all the transform stuff, the position, rotation, the scaling of each different item. It's got some parent-child dependencies going back and forth, so it can change between that. All the base stuff you'd expect from a transform class, especially with the parent and child's kind of going down by multiplying. We also have simple emitter class that controls all the effects. Not super important. I've got a game state manager right here that keeps track of different states. When it sets a new state, it creates the scene tests or scene menu or whatever object. They each have each derive from the same base class, which is scene, and they can always just kind of create the new one they need. Also sets the camera. Every single object that is drawn also multiplies by the view projection matrix of the camera, which is somewhere here. Yeah. It uses singletons for simplicity so that I could just grab it from wherever. It uses the width and height of the app so it can keep track of it very easily. It uses right now just an orthographic matrix to kind of keep it simple with the 2D aspect. No point of making anything more complex, but every time it goes through the app draw line function, it kind of has the MVP matrix kind of called in advance. So it's got the model that's being sent and the view projection that's being created from the global camera one, so that as the camera's moving, every single vertex is going to kind of move around. The vertices are being stored conveniently with this vertex class, which just kind of stores all of the data that's needed in these arrays. It keeps different modes for different buffer types and different drawing types. And it also recreates the arrays if necessary or resizes them. All super compact. And then I've got my scenes right here that just have all the necessary scene objects that's going on. So the main one that is going to be created a lot are the special objects right here that inherit from game object. Game object is kind of a global class that just has components that can be added to it, which uses the component system for the transform, rendering, which was shown before for the vertex, and also rigid bodies and collision, all that stuff. The rigid bodies are very simple. They just keep track of the velocity, gravity, little stuff like that, then affect the transform class. And since they're both components of the same game object, they can be accessed really conveniently. And then the collider class, which is just kind of this base class, actually gets inherited by whichever one it needs to, like the line collider class, which just, keeps track of collision for the lines, and then the circle class for the circles. Not much time was really made for the ABB stuff, but circles and lines were the core ones I wanted to focus on. And the collision math class right here has all of the collisions kind of templated for simplicity, but over here, every single combination that was needed just kind of gets calculated and returned. So there's two sections, one for checking collision and a bool, and then the other one resolve collision, depending if it's a trigger or if it's a collider, depending on whatever collider type it is. Naming conventions weren't always super great at certain times when classes ended up being needed to do multiple things. But for the most case, it's just check collision. If it's not a trigger, it just resolves the collision, just like that. And if I go back here, you can see that this ball right here is a game object, and it just has the circle collider. Every time it's moving around, it just reacts to it, such as the lines and the circles that have their own lines or circle colliders, and then just react based on the bounciness, I guess. it's kind of a lot going on here. The circle to circle was fairly easy, a lot of kind of bouncing based on wherever the other circle is, and it kind of uses the reflect vector for simplicity. The line to circle collision was a bit more complicated, but it ended up also doing checks for tunneling and whatnot, and kind of repositioning just to be safe. And yeah, that is pretty much the core of what everything was done here. There's a lot of classes because there was a lot of setup done in advance for just math related things, but the general gist of it was that I used all the physics I wanted to do in the short time I had, and I got this nice little pinball game. Well, it's usually working. Thank you for listening.